Okay, Assalamualaikum and good day, everyone. Okay, now, since I did get a request on the explanation of formal charge and resonance, I think I would like to share the discussion on one past question, on the related topic. Okay, now let's have a look at the definition first, of formal charge. Okay, what is the definition of formal charge? It is actually the charge of individual atom, which makes up the total charge of the substance. Yeah. So if you look at the definition in your notes, it says apparent charges on a certain atom in a Lewis structure. Yeah. Normally, what is it used for? It is used to for us to determine the total charge of a substance and also to find the most plausible Lewis structure. Most plausible here means the most accurate and the most um, the best, the best in terms of charge, which is more logical according to chemistry concepts. Okay, so now let's have a look at the question that I would like to discuss today. It says that explain the following statement of the three possible resonance structures for OCN minus 3. Yeah, structure number 3 is the best structure and you need to explain why. Right. If we go back to the requirements or the characteristic of the most plausible structure, the most accurate, the most logical. Okay, number 1, the formal charge should be very close to zero as possible. If we can get 0, 0, 0, that means every single atom in the substance has a formal charge of 0. That is the best formal charge possible, right? And therefore, that is the most plausible Lewis structure. However, not every substance, every molecule has a charge, a net charge of 0. Therefore, the second characteristic will be if we have the negative formal charge on the more electronegative atom, that is also good. Or vice versa, the positive formal charge on the more electropositive atom. Okay, what is the formula for calculating formal charge? Okay, look at the one given here. The formal charge equals to the total number of valence electron minus the summation of the number of lone pair plus half of the number of bonding electrons. This is the formal formula, formal formula. But normally, marks will be given for the set of accurate formal charges. That means you need to calculate so many formal charges and that only gives you 1 mark. Therefore, I will teach you the fast way to do it. But still, you need to know this definition. Okay, so now let's move on to the question. And structure number 1, we have OCN minus in which you have double bonds here. But don't get me wrong, if the structures are given like this, that means, of course, the lone pairs are not shown, Okay, let's show our lone pairs, Okay, so oxygen here has 2 double bonds. That means 1, 2, 3, 4. So the other 4 are lone pairs. 1, 2, 3, 4. And of course, nitrogen as well. Yeah. Here, 1, 2, 3. Therefore, only 1 lone pair. Carbon 1, 2, 3, 4. And nitrogen 1 only. Therefore, there are 3 lone pairs. And for structure number 3, we have 1. Therefore, 3 lone pairs. To complete the octet, I mean, Okay, because these structures are given. Yeah, only the lone pairs are not shown. Of course, if you construct your own Lewis structure, you will actually show the lone pairs automatically when you draw the Lewis structure. And here, 1, 2, 3, therefore, one lone pair only. Carbon is fine. It has 4 pairs of electrons. Okay, now let's calculate the formal charge. Okay, number 1. Okay, refer to the formula. I think you can refer to the formula, but now I'm going to show you the fast way to do it. Okay, number 1. Okay, can I use maybe green here? Can I get green? Come on, green. Okay, it doesn't want to give me green, no problem. Okay, let's calculate every single formal charge. Yeah? Okay, for oxygen, we're not forgetting our lone pairs just now. What is the number of valence electrons for oxygen? Okay, oxygen has 6. Minus, minus how many dots around oxygen? Which means how many lone pair? How many dots? 4. And how many bonding electrons? If you refer to the formula, it says, the number of bonding electrons, which is 4 here, must be multiplied by half. So we just refer to the number of dashes, the number of bond. We have 2 here. Okay, and that gives us 6 minus 4 minus 2, that equals to 0. Exactly. Okay, that is the best formal charge. And then for carbon, we have 4 valence electrons minus. Okay, do we have any lone pair around carbon? No dots, therefore 0. How many dashes or how many bonds? 1, 2, 3, 4. So 4 here. And that also gives you 0. And finally, we have N. N here, okay, remember we have all the dots, 4. Okay, how many valence electrons? 5 minus. Okay, how many dots? 1, 2, 3, 4. So 5 minus 4. And then how many dashes? How many bond? 1, 2. So 5 minus 4 is 1 minus 2 is negative 1. Right? Remember, charge must have positive or negative sign except for 0. Okay, now let's move on to the second structure. I think we can do this faster now. Yeah. Okay, we have oxygen. Okay, let me just put in the lone pair. So that will be easier for us to calculate. 3, 5, 6. Okay, 1, 2, 3, 4, 5, 6. If you're wondering, how do you know how many lone pairs we have? We just complete the octet. That's it. Then what we have here, 1, 2, 3. All right. So we have 4 pairs of electrons. Okay, now oxygen. How many valence electrons? 6 minus 2 dots. And then minus 3 dashes. That gives you positive 1. Carbon. 4 valence electrons minus. Do we have any dots around carbon? No. So 0 minus. How many dashes? How many bonds? 1, 2, 3, 4. So 4 minus 4 is exactly 0. And nitrogen, the last one, we have 5 valence electrons minus. Okay, how many dots around nitrogen? 1, 2, 3, 4, 5, 6. Okay, and then minus 1 more. And that gives you 5 minus 6 minus 1, which is just negative 2. Okay, and the last one, okay, let me use a different color so that hopefully it can make it clearer to you. Okay, now we have oxygen. Oh, still red. Okay, come on, I want green. Green, green, come on, green. Alright, so green here. Okay, 6 valence electrons minus how many dots around oxygen? We have 6 and how many dash? 1 only. Therefore, 6 minus 6 is 0, minus 1 is negative 1. Yeah, show the negative sign. Okay, and then carbon, we have 4 valence electrons minus. Yeah, do we have any dots around carbon? No, therefore 0 minus. Okay, how many bonds? 1, 2, 3, 4. Yeah. And that gives us 0. And finally, for nitrogen, we have 5 minus dots, yeah, 2 dots there. And then minus 3 bonds. And that gives us 5 minus 2 minus 3 is 0. Okay, now let's check. Remember, the total of the formal charges must equal to negative 1. So, do we have negative 1 here? Yes, 0 plus 0 plus negative 1 is negative 1. And here, the total is also negative 1. And here, the total is also negative 1. That means we have calculated our formal charges correctly. Okay, now, which one is the best? Okay, here, for the structure number 2, I think we can eliminate this from our answer. Yeah, we can neglect this as our answer. Okay, because as you can see, it has positive 1 and negative 2, which is quite far from 0. Alright. Okay, by the way, the answer is given, yeah, as number 3. Okay, what is the difference between structure 1 and structure 3? Look at the numbers. 0, 0, negative 1. And here is also 0, 0, negative 1. Okay, of course, 1 and 3 are actually plausible if we refer to the first characteristic. What is the first characteristic? It must have the lowest, yeah, the lowest formal charges. And when we say lowest, it means approaching 0. Yeah, all the formal charges are approaching 0, very close to 0. Okay, now, but we have 2 of that. So how do we decide? Let's go to the second characteristic. Okay, now we have negative formal charge. And the one which is better is the negative formal charge must be on the more electronegative atom. Okay, on the more electronegative atom. And, okay, I think we can see here the negative formal charge is on nitrogen. And on structure 3, the negative formal charge is on oxygen. Which element is more electronegative? Nitrogen or oxygen? Of course, the answer is oxygen. Yeah? That's why structure 3 is the most plausible structure. And what is the reason? Because, yeah, the negative formal charge, yeah, is on oxygen atom in which, yeah, in which oxygen is more electronegative than nitrogen. Okay, excuse my handwriting. Right? Then nitrogen. Okay, all right. I hope this helps. Yeah. All the best for the SPM.